Well, now we're doing a review question for section 5-5, and we've got to find the absolute extreme of this equation. F of x equals x to the fourth minus 8x squared plus 16 on the interval 0, 2. So let's evaluate f of 0. And if we do that, we get 16, as you can see. If we evaluate f of 2, replacing x with 2, we're going to get 0. 2 to the fourth is 16, plus that 16 is 32. And 2 squared is 4 times negative 8 is negative 32, and that adds up to 0. So now let's find the first derivative, so we can find our critical values. And that equals 4x cubed minus 16x. And now if we factor a 4x out of each term, we get x squared minus 4, and this factors, and that's going to be 4x times x minus 2 times x plus 2. So we've got critical values at 0, negative 2, and 2. So let's sign this graph of the relative to the behavior of the derivative on these intervals. So if x is like negative 1, which is in this interval, that'll be negative, and that'll be positive. So the product of an even number of negatives is positive. If x is 1, we'll have positive, negative, positive, and the product of an odd number of negatives is negative. And finally, if x is greater than 2, we'll have all positives. Okay, now we know what the behavior is on the intervals of interest. Let's find the second derivative, f double prime of x. And that's going to be 12x squared minus 16. And if we factor that and take a 4 out of each term, what we get is 3x squared minus 4. And that factors, and what we get is 4 times root 3x minus 2 times root 3x plus 2. And that has zeros at f double prime of x equals 0 at x equal plus or minus 2 over root 3, which corresponds to, when we rationalize the denominator, 2 root 3 over 3. But we're only interested in the positive because we're going to graph, or we want to find the extrema on 0, 2. So we're just going to let x, and when you make an approximate this value, you get approximately 1.2. And we're only concerned, as I said, with the positive. So now let's graph it. So here we are at 0, 16. Here we are at 2, 0. And here's a 1.2. And there's going to be an inflection point in this curve at x equals 1.2. But notice, this curve has a positive slope from negative 2 to 0. So we're coming at it from down here. It has a negative slope from 0 to 2 and an inflection point right here. So I'm going to draw that inflection point, and we're going to change our concavity and go up. And notice f double prime, if you look at f double prime of 0, that's going to be negative. Negative concavity, maxima. If you look at f double prime of 2, that's going to be positive. So f double prime of 0 is less than 0. Try them out. F double prime of 2 is greater than 0. So we're going to be concave up on that interval. Our extrema, our absolute ABS max, is 16 and occurs at x equals 0. The ABS min, absolute min, is 0 and occurs at x equals 2. And we're done.